Consider these two cars. Let's name them A and B. Suppose this car A is moving with a velocity 60 meter per second towards left, and this car B is moving with a velocity 80 meter per second again towards left, and these velocities 80 meter per second and 60 meter per second respectively are the velocities with respect to ground. Now for this car A, the car B will not appear to move with the velocity 80 meter per second towards left. It will indeed appear to move with the velocity 20 meter per second towards left, because this car A already has a velocity which is 60 meter per second towards left. Consider this another case. Suppose there are two cars again. Let's say this is A car and this is B car. This is moving in right direction with a velocity 40 meter per second, suppose, and this is also moving with a 40 meter per second velocity but in opposite direction, that is towards the car A. Now for the car A, this car B will appear to approach faster than this velocity 40 meter per second, because it is having a 40 meter per second velocity in the direction of that car B, and this velocity will be 80 meter per second for this car A. So this car B will appear to move with 80 meter per second towards car A for an observer in car A, and for an observer in car B, the car A will appear to move with 80 meter per second velocity. So this velocity is different in different reference frames, and we have to define a reference frame to do our numerical calculations. So consider this case. Let me go back and discuss the formula of the relative velocity. So the relative velocity V bar of an object B with respect to object A is given by V bar, the velocity of object B, minus velocity of object A. And these velocities V bar B and V bar A are the velocities with respect to ground. So in this case, for velocity of B is 80 meter per second towards left, let's say the left is the positive direction and the right is the negative one. So this is 60, sorry, it is 80. This is 80 meter per second minus VA, which is 60 meter per second. So the answer is 20 meter per second. So velocity of car B with respect to A is 20 meter per second. Now in this case, velocity of car A with respect to B will be velocity of A minus velocity of B. Again, these velocities are with respect to ground. You can write a G over here, so to indicate it is with respect to ground. So velocity of A, let's say this is the positive direction and this is the negative direction. So this is our convention. So velocity of A with respect to ground is 40 meter per second minus velocity of car B with respect to ground is 40 meter per second again, but with the opposite sign, because this is left side is negative side, so this will be plus, so this becomes 80 meter per second. And similarly V bar BA will be V bar B minus V bar A. This is G and this is G, so which is minus of V bar AP. So this becomes 80 meter per second with a minus sign. So this indicates that the car B will appear to approach towards car A in this direction, that is the left direction. So hence it is minus. And for this car B, the car A will appear to approach in this direction, and that's why it is positive. Now consider one problem. Suppose there is a trolley like this, and this trolley is moving with a certain velocity. Let's say that velocity is 40 meter per second. Not 40 meter per second, let's say it is 20 meter per second. And there are two persons standing at the end of the trolley, and let's say the length of the trolley is 200 meter. Let's say this person, let's say it is A person and this is B person. Let's say this person throws a ball here in this direction with a velocity of 40 meter per second. That is the velocity with respect to trolley. Let's consider this speed with respect to trolley. So velocity of the ball B with respect to trolley T is equal to 40 meter per second, and it is in plus direction, that is towards right. So this is the velocity. Now what will be the velocity of this ball with respect to a observer standing on a ground? This observer is not moving, this is stationary observer. Now let's calculate. We know velocity of an object B with respect to T is equal to velocity of B with respect to ground minus velocity of T with respect to ground. Now we have to know this quantity, that is velocity of ball with respect to ground. So let's take this over here. So this becomes VBT plus VTG. This is equal to VBG. This is velocity of ball with respect to ground. Now velocity of ball with respect to trolley is 40. This is plus because it is moving in the right direction. I forgot to write a convention over here. So this is right and it is positive, and the left will be taken as negative. So this is plus 40. Velocity of trolley with respect to ground is in this direction again. So this is 20 meter per second, and this is again meter per second. So velocity of ball with respect to ground is 60 meter per second. Now what if this person B throws a ball with 40 meter per second velocity in this direction, the left direction? I'm assuming infinite acceleration over here because I want to deal with the uniform velocity. So in no time this ball acquires 40 meter per second speed. So let's say this person now throws the ball with a 40 meter per second velocity in this direction towards person A. Then what will be the velocity of the ball with respect to a stationary observer on a ground? So now velocity of ball with respect to ground is to be found out, and velocity of ball with respect to trolley. Now this velocity 40 meter per second is with respect to trolley. So this person has thrown this ball with the velocity 40 meter per second with respect to the trolley. So why it's not going? Yes. So velocity of ball with respect to trolley is 40 meter per second in the negative direction, hence minus sign. And we have to know velocity of ball with respect to ground. Again apply the same formula. Velocity of ball with respect to trolley is velocity of ball with respect to ground minus velocity of trolley with respect to ground. Velocity of ball with respect to ground is to be found out, so this is VBG. This becomes VBT plus VTG. So VBG becomes, VBT is minus 40 meter per second, VTG is plus 20 meter per second. So this becomes minus 20 meter per second. So this ball will move in the left direction for this stationary observer with the velocity 20 meter per second. Now what is the time taken by this ball to reach this person B from this person A? So this will be, so what will be the time taken? To reach from person A to person B. We know that this trolley is moving with a certain speed, 20 meter per second. And these persons are also moving with a 20 meter per second velocity towards right. Now, if I work in this frame of reference where the velocity is 20 meter per second with respect to ground, then I will assume this trolley is at rest. So I'm working in the frame of reference of the trolley. So for this, then this length is given 200 meter. So just divide this 200 meter length by 40 meter per second. So this 200 meter length divided by 40 meter per second, because this 40 meter per second velocity of ball is with respect to trolley. So for the trolley, it is moving with a 40 meter per second velocity. And now I am working within the frame of reference of the trolley. So that's why I have written 40 meter per second here, and this is 200 meter. So this becomes 5 seconds. So it will take 5 seconds to go from point A to point B. Now, what will be the time taken by the ball to go from person B to person A? Again, use the same logic. Work again in the frame of reference of the trolley. The frame of reference of trolley. In the frame of reference of trolley, this ball will have 40 meter per second velocity again towards left. Why? Because this velocity is with respect to the trolley itself. So this will be again 200 meter divided by 40 meter per second. So this becomes 5 seconds again. So to go back from B to A, it has used 5 seconds time. Now consider this problem. Suppose this is position A and this is position B. The position A is a railway station and position B is a popular tourist place. So from the railway station to popular tourist destination, the tourists usually travel. So, and they travel again back to the railway station. Let's say this point A and B are 1 kilometer apart from each other, and there is a taxi service which provides the taxi from position A, and this taxi leaves from position A every T minute. So every T minute a taxi leaves from position A, and from position B also every T minute a taxi leaves. And assume that the taxi moves with a certain velocity, let's say v meter per second. So this is the velocity of a taxi. Now there is a cyclist who is traveling in this direction, with a 10 meter per second velocity, and every 2 minutes he encounters a taxi coming from position A, that is moving in the same direction as that of a cyclist, and every 1 minute he encounters a taxi which is coming from B, that is in the opposite direction of his motion. So this is from B every 1 minute. Calculate what is the T, that is the time T period that the cab or the taxi leaves. So consider this. Let's solve this. So this is 10 meter per second. This 10 meter per second is the velocity of the cyclist. Consider this. Suppose the cyclist is at this position, and at this position the cab which has left from position A meets him here. Let's say this is the first cab. The next cab will be some distance away from the first cab. And what will be this distance? See, every t minute the cab leaves from position A. So after the cab 1 has left, t minutes after that cab 2 has left. So this distance will be the velocity of the cab V times the t. So the cab 2 is a Vt apart, that is the distance Vt apart from the cab 1. And this 2 is covered in 2 minutes, because every 2 minutes the cyclist encounters a taxi coming from A. So this will be distance Vt divided by, now this distance is covered by the taxi with respect to the cyclist in 2 minutes. So I have to write the relative velocity over here. So with respect to cyclist, what is the velocity of the cab? The velocity of the cab will be V minus 10. Assume that the right direction is positive and the left direction is negative. So this is V minus 10, and this is time. So this time is 2 minutes. So this will be 2 into 60, which is 120 seconds. So I have got this one formula. Vt upon V minus 10 is 120 seconds. Now similarly we will do this for the cab coming from position B. Let's say now the cyclist is at this position B, at this position, and he meets the cab here at this position. Let's say this is the first cab which is coming from position B, and then again the second cab will be some distance away, which is nothing but V times t, that is velocity of the cab times the t minute, because only after t minutes the second cab will leave, and the velocity of the cabs is V, so this distance will be Vt. So in time t, 1 minute, every 1 minute from position B, this cyclist will encounter the cabs. So this will be Vt, that is the distance. Now with respect to the cyclist, the velocity of the cab will be V minus of minus 10, which this is equal to 1 minute, because every 1 minute the cyclist will encounter the cab coming from position B. So this is the relative velocity, V plus 10. So this will be Vt divided by V plus 10. This will be 60 seconds. Now let's solve it. Let's take the ratio of these two. Let's say this is 1 and this is 2. Let's take the ratio of these two. So this will be V plus 10 divided by v minus 10, which is equal to 2 seconds. So 60 by 120 is 2. Sorry, 120 by 60 is 2. So this becomes v plus 10 times 2v minus 20. So v goes there and this is 30. So velocity of the cab or the taxi is 30 meter per second. So we have calculated the velocity of the taxi also. Now what is t? Now we know the velocity of the taxi. So 330 into t divided by 30 minus 10 is equal to 120. So I have just substituted the value of v in equation 1. So this becomes 30t is equal to 120 into 20. So this is 2400 and 30 will come here. So this will be t seconds. So let's cancel this 0. So this becomes 80 seconds. So then in minutes it will be 80 divided by 60, because 1 minute is 60 seconds. So this 0 gets cancelled and then it is 8 by 6 minute. So every 8 by 6 minute the cab leaves.